Alright, again, this is a video just to help you if you get stuck in some places so you can go over and kind of check what I'm talking about. So we talked about regular Punnett squares, and we talked about genes that are on these chromosomes. So these are all chromosomes, 1, 2, 3, 4, 5, 6, so on and so forth. We have 22 pairs, or 23 pairs, this is a pair here, alright, for 46 chromosomes. Before we were talking about genes on pairs 1 through 22. All right, these genes were just the big A or little h or big T or whatever you're talking about genes. Now we're going to talk about genes on the X and Y chromosome. All right, so the first part here of the paper is just to make you look at what is different and similar between Fred, who's a male, and Wilma, who's a girl. So what differences do you notice? So if you look at these chromosomes, I kind of give it away here of what's different and the same, and you want to figure out who is why males are males and why females are females, because females will always have this and males will always have that. All right, so then down here, this one's easy. You should be able to do this. You just use this chart up here. Use this chart right here, all right, to tell the phenotypes down here. So you just use the genotypes again to tell what the phenotypes are. So big N, little n would be dominant, so he's normal. All right, and so that should be pretty simple. I'm not going to spend any more time on that one. The next page, this is where it starts getting a little complicated. All right, so I'll do the first one for you. See if you can figure it out here. All right, so what's the percent chance that Pebbles, their daughter, has faulty enamel? What's the percent chance that Pebbles has normal enamel? All right, so let's go up to Pebbles, and let's find the enamel. So faulty tooth enamel is dominant in this one. Normal tooth enamel is recessive. So let's look at, so Fred is X big EY, and Wilma is X little e, X little e. Alright, so first of all, Fred is a boy, so that's why he has a Y chromosome. And Y chromosome has no genes on it, so you're going to write this just as their genotypes are. So the X chromosome has this big E on it in Fred. In Wilma, the female, she has two X's, so she has two genes. Fred only has one because the Y doesn't carry anything. The Y is a very short chromosome. So if we do this, you just do it like a regular Punnett square. You bring this X big E down to those two boxes. These X's across with the little E on them. And then this Y down. Alright, so now what is the percent chance that Pebbles, their daughter? So what we need to do is just look at the daughter. So the daughter are just these two right here. So you can actually physically cover up, you can't see what I'm doing, you can actually cover up the boys and just look at the girls. So if you look there, faulty enamel is dominant, and she has two big E's. So Pebbles has a 100% chance at getting faulty and a 0% chance at getting normal. Alright, so now we'll go Bam Bam. Bam Bam's the son, so we can look at just here. So now we can cover up the females. Bam Bam has no dominant. He got both little E's from his mother. He only got the Y from his father, so he didn't get any genes from his father. Alright, so if we look here, Bam Bam, their son, has faulty enamel. He has 100% chance of normal because he's all recessive, and 0% chance of faulty. So who has the higher chance, Bam Bam or Pebbles? It is Bam Bam of getting the recessive gene of normal. Alright, so what you're going to do is you're going to do the other four that are on here, or the three. 1, 2, 3. And then you're going to look through and answer these questions. So the things that you're should get out of this is one, how to do those Punnett squares. And then you want to look at these questions here, which some of them I kind of answered as I was going through, but I want you guys to figure these out. Alright, so why are males more affected by recessive sex-linked diseases more often than females? Who do males always receive their genes from if the trait is sex-linked? And if a male has a disease that is X-linked, what percent of his sons will inherit the disease? All right, so I want you to think about those and go back and look at your examples to try to figure it out, because these are the main gist of what you need to get out of this. All right, so that is just an introduction to sex-linked genes.